So we're doing some more simplification with radicals. First here we have a subtraction, and when that happens you have to get like terms, well, like radicals is what you would call them. So these are square roots, so you want to pull out all the perfect squares that you can there. So we've got a 4x squared out in front, and then the 27 is 3 times 9. 9 is a perfect square, so we can break that up as 9 times 3x. And then minus 2, and then x cubed, that has a perfect square in there, x squared. So we've got a square root. Let's break that product up. We've got x squared out in front times, we'll have a 3 left, and then an x left. And then in our next step here, we can break those products apart. So this will be 4x squared. And then we can break up the 9 and the 3x. So root 9, root 3x, minus 2, and then do the same thing here. You can break products and quotients apart underneath square root. So root x squared, root 3x. And then square root of 9 is 3. 3 times 4x squared will be 12x squared. And then we've got that root 3x left. And the x is under the root. And then square root of x squared is x. The square root and the square undo each other. So this will be minus 2x square root 3x. And now we've got like terms. So when you got like terms, you add or subtract the coefficients. So if this was, 3x minus 2x, you would subtract 3 minus 2 and you'd get x. Well, instead of x, it's square root of 3x. So those are our like radicals here. So let's pull that root 3x out on the right. And then we subtract our coefficients here and here. So we will have 12x squared minus 2x, that quantity, times the root 3x. Next up, we got some rational exponents. We're multiplying here, so we're going to add our exponents. So this will be 3 times y to the power 1/2 plus 3/5. And when you're adding fractions, you got to get a common denominator, which in this case is 10. So in that first fraction, we multiply by 5 over 5 to get an LCD of 10. And in the second fraction, we multiply by 2 over 2, again, to get that LCD of 10. So this will be 3 times y. And then this is 5 over 10 plus 3 times 2, 6. 5 times 2, 6 over 10, which is 11 over 10. So 3 times y to the 11/10 power. And that one's done. And now we've got a cube root here of a quotient. So we can take the cube root of the top and bottom separately. So cube root 625 over cubed root z to the 7th. And then to simplify cubed roots, we want to take out perfect cubes as much as we can. So 625 is actually 5 to the 4th power. It's 5 times 125. So we will break that 625 up as 125 times 5, because 125 is 5 cubed. It's a perfect cube. You're breaking off perfect cubes as much as you can. Do the same thing with the 7 factors of z. We can break that up as z cubed times z cubed times z cubed root. And now we can break these products apart. So cubed root 125 times cube root 5. And in the denominator, cubed root z cubed times cubed root z cubed, and then cube root of z left on the end. So now a little bit of simplifying here. So cube root of 125, that is 5. 5 is the number you cube to get 125. Times cube root of 5 is left over. In the denominator, cube root of z cubed is z. Cube root of z cubed is z. The cube and the cube root undo each other. So there's 2 factors of z, so z squared. And then we've got a cube root of z left over. And that is an answer. It's not simplified, though, according to usual standards. They don't like to have irrationals in the denominator. So we need to multiply by the missing factors that make that a perfect cube. Do that top and bottom. And that will be cube root of z squared. So you got 2 factors of z there. 1 more there will be 3 factors. Up here, same thing. Cube root z squared. So all we did was multiply by 1. And now multiplying straight across, these are both cube roots, so we can multiply them underneath the cube root. So this will be 5 cubed root of 5z squared. And then in the denominator, again, we can multiply those underneath the cubed root. So we got a z squared out in front. Cubed root of z times z squared is z cubed. And then, again, the cube and the cubed root cancel each other out. They're inverses. Z is left. So I got 2 z's, 1 more z. That's z cubed in the denominator. So this will be 5 times the cubed root of 5z squared all over z cubed. And that one's finally simplified.